Redox Equations. This is called Basics 2, and I think it'd be good to start with from Basics 1, the general concept of redox equations. Redox equations involves a loss of electrons is oxidation, and a gain of electrons is reduction. We said Leo the lion says grr. There he is. That's a scary Leo. I don't mean the lion, I mean the drawing. So loss of electrons is oxidation, gain of electrons is reduction. So let's apply this to an equation. We're going to start off with a compound that's iron 3 oxide. Iron 3 oxide. That's a stock system. This is a 3+ ion. Means iron. This is a 2-. So this is Fe2O3. It's a solid. The most common iron oxide used in steel making was hematite. If we react it with carbon, now this carbon comes from coal, probably bituminous coal in the United States, and the bituminous coal is heated in the absence of air and changes to a substance called coke. It's just a higher content carbon than the bituminous coal that can run maybe 80–85% carbon. This runs it up higher. So if this reacts in a lot of high temperature, you can get Fe, which is a solid, and carbon dioxide. Now this is a very famous equation. This equation is the equation of making iron. And even more specific than iron is steel. Steel is an alloy of the element iron, which combines carbon. It combines, here's the iron atoms. We'll just line them up real simple here. And the carbon atoms get into the spaces in between. And they're called interstitial alloys, and this makes the iron maybe 1,000 times stronger. This whole process was developed by an Englishman in around the mid-1850s, 1853 to 55. His name was Bessemer. Bessemer is a poor guy in London, young man, who became one of the richest guys in London with his inventions, and the main thing is the Bessemer furnace. It takes the iron oxide, the carbon, and also some calcium carbonate we'll mention later, and made iron, which is converted, which becomes actually steel because the carbon got into the iron crystal structures. Well, let's check this out. In terms of oxidation numbers, the iron goes from and let's erase, get that out of there so we can put oxidation numbers in. The iron here is +3, oxidation number, and here it is 0. Iron is going from +3 to 0. How does that happen? Iron going from a +3 to a 0 state. +3 means deficient 3 electrons. So to become neutral, it has to gain electrons. There is Leo the lion says grr. There's grr. Gain electrons. Reduction. What caused the reduction? The answer is the coke. The coke, and it's partially oxidized to carbon monoxide. They are both oxidizing, or both reducing agents. They reduce. They cause the reduction. They reduce the iron ore. The old definition of reduction, and I think it's worthwhile putting that in. The first definition of reduction, before we dealt with the gain and loss of electrons, reduction really was the loss of oxygen in a compound. So oxidation was a gain of oxygen. And if you look at this reaction up here, you see the iron ore. And notice I said iron ore. Ore is a mineral that can be mined for profit, a metal out of it. You can mine a profitable metal, ore. The ore is reduced to iron. The oxygen is taken out, whereas the carbon has gained oxygen. So that's oxidation. But that's a very old-fashioned definition. The main thing we need to remember, on the other half of this equation, carbon has gone from 0 to the oxidation number here, +4. Now, how did that happen? That is a loss of electrons. Carbon is neutral here. Let's get the right color here. Carbon is neutral here. And it became, in CO2, it became +4. It means it lost 4 electrons. Okay, that's oxidation. We would have to balance this out, find a common number between 3 and 4 electrons. That would be 4, and this would be 3. So you get this equation balanced. 4 iron, and we could go up here and put, we have 2, there's 4 iron, 3 carbon, 3 carbon monoxide, and 4 iron over here. So let's check this out. 4 iron on the left, 4 iron on the right. 3 times 2 is 6 oxygen on the left, 6 on the right, 3 carbon on the left, 3 carbon on the right. So it's balanced by these two half reactions. That's a redox equation. Now let's check this one out. This equation is an ancient equation. This is one of the first processes of mankind in recorded history, where they took a substance called limestone, calcium carbonate, and they heated it to low temperatures, maybe 500 degrees Celsius. That's why it worked so well. And they made a substance called lime, calcium oxide, and they got carbon dioxide. Now this lime right here was used in, it was used in the glass industry. It was used as a mortar mix. You mix it with water. It was even used by the theater people that it glowed white in a high temperature, about 2,500 degrees Celsius. So they would say, put you in the limelight. It's not used anymore. But that's the word where the limelight came from. So let's check this out. Let's check this out. Redox, huh? Calcium is +2. Oxygen is -2. Carbon is +4. Calcium is +2. Oxygen is -2. Carbon is +4. Oxygen is -2. Well, go ahead and find the redox, the half reactions here. And the answer is, this is not a redox equation. Not a redox equation. So not all equations are redox. Okay, so we've had 2 equations. Both are very interesting industrially. One is very much a redox equation, and the second one isn't. And if you want to review this redox equations, go back to Redox Basics 1. We'll stop there.